Well, let's talk about how we deal with these atomic symbols. So I've got calcium here. And I've got this 40, this 20, and this 2 plus. So let's talk about what all these numbers are. First off, the 40, the top number here. That is the mass number. Now, mass number is not to be confused with atomic mass. I know that's highly confusing because they sound very similar. But atomic mass, or as we'll call it, average atomic mass, is different than the mass number. Mass number applies to a single atom, whereas average atomic mass applies to a sample of atoms. So again, we're looking for mass number when we talk about a single atom, and that is simply the protons. I'm going to abbreviate that as P plus because they're positively charged, plus the neutrons. I'm going to abbreviate that as N sub-0 because neutrons are neutral. So mass number, that is this 40 right here. That is the protons plus the neutrons. So this number down here, that's the atomic number, probably the most important number for an element, because this is the number of protons. And the number of protons decides what element it is. So atomic number tells you just the number of protons, and that tells you what element it is. So if I just knew it was element number 20, I could look at my periodic table, find number 20, and say, oh, that's calcium. Neutrons don't determine the element. Electrons don't determine the element. It's protons. So protons determine what element this is. So atomic number is super important. It tells us the element. So if I know 20 or I know calcium, these two things tell me the same information. So they're basically the same thing. That's why sometimes you won't see the atomic number written. You'll just see the mass number, because if it's calcium, I know it's number 20. It's technically redundant information. I already know what its atomic number is. Okay, and then up here, we've got the net charge. The net charge. So our net charge is going to be your protons minus your electrons. So if your net charge is neutral, that means that you have the same number of protons and electrons. If your net charge is positive, like in this case, you have more protons than electrons. And if your net charge is negative, it means you have more electrons than protons. So typically what we'll do when we have this information is fill out this chart here, or vice versa. If we have this chart, we'll fill out the symbol. So for protons, we look at the atomic number, and there are 20 protons here. So again, to get the protons, that is just our atomic number. So that's probably the easiest one to get. For neutrons, well, the only one of these numbers that includes anything about neutrons is the mass number. But mass number, you'll see, is protons plus neutrons. So that means to get my neutrons, I must do the mass number minus the atomic number. Because it's basically, I'm doing protons plus neutrons, that's the total, minus just the protons, gives me just the neutrons. So I'm just subtracting it out. In this case, protons and neutrons are the same. That definitely doesn't happen every time. So in some of your lower elements, like first 20, that's kind of common, but as your elements get heavier, that becomes less and less common that you have the same number of protons and neutrons. So you have that in this case, but not in every time case. And then finally, electrons. So in this case, I have 18 electrons. And I figured that out by doing the atomic number minus the net charge. And that's because, again, net charge is protons plus electrons. So I just subtracted out what my difference was. I knew I have more protons because it's positive. So I have 18 electrons. So 20 minus 18 would give me plus 2. So it's a little bit of algebra. It's just a little bit of really simple algebra there, rearranging this equation here. So net charge equals protons minus electrons. So that means electrons equals protons minus net charge. Same thing here with the mass number. If mass number equals protons plus neutrons, that means neutrons must equal mass number minus protons. So just a little bit of equation rearranging there. And so that's how you figure out protons, neutrons, and electrons from our atomic symbol.